Sup everybody, today we're gonna do something special. We're gonna recreate Flappy Bird in Unreal Engine using no code whatsoever. This will be a 3-part series, and by the end of it we'll have something that looks like this. Okay, no, it's not Flappy Bird, okay? It's Flappy. It's my own version. We're gonna be using the sprites that I made for Flappy Bird. It's pretty much the same. Oh, and I'll leave a link in the description where you can download the sprites if you want to use the same as I'm using. It might be good if you do that because then everything will be the same and you won't be confused by anything. So I definitely recommend doing that. Now this is obviously for complete beginners, but I would recommend that you've at least opened Unreal Engine before and have some understanding of what's going on. Maybe played around a little bit with blueprints and stuff like that. But yeah, this is gonna be really basic. So if you haven't done much before, that's totally fine. But I would definitely recommend just familiarizing yourself just a little bit with the engine first. Let's get going. All right, so the first thing we want to do is we want to make sure to create a new project. We're going to make it blueprints because obviously we're not going to use any code. We're just going to start with a blank project. We don't really need any of this stuff. So, pick your folder, Flappy Bird, Flappy Fart. All right, so you'll be faced with a scene like this. So the first thing we're going to do is we're just going to go and delete. We can keep this. And the next thing we want to do is just save our level quickly. So we'll name it Flappy level. I mean, we'll only have one level in this game, so it doesn't really matter, but still needs a level. So before we do anything else, I want to import all the files we need so that that's out of the way. So if you've downloaded the folder, you'll find that there are 2 folders, sound and sprites. So you can just select them and drag them into your hierarchy and you should have it in here. All right, so you'll have 2 folders, sounds and sprites. So you might notice that this looks a little funny down here, and if you open it up, you'll notice that it looks really blurry. Now this is not good. Obviously this is pixel art, and what it's doing is it's scaling it up and it's trying to interpolate it. Now we don't want that. We want a clear, crisp look. So you can go in and adjust the settings here manually, but it's generally better to just right click and sprite action and apply paper 2D texture settings. Much better. Okay, look at that. Perfect. So you want to do that on all of these. And that's it for that. All right, great. Now that's out of the way. Let's think about this. First thing is to just get the character in there and get it moving. So why don't we just start with that? First, let's make a folder. Let's call it blueprints. This is where we'll be creating all our blueprints. So start by just create a basic asset, blueprint class, and all right, generally you want a character if you want to be able to jump around and stuff like that. But since our character is so simple, and we want to design the jump mechanic ourselves, I really don't feel like a character is necessary. It's just going to come with a bunch of bloat. So I think pawn is the base class of all actors that can be possessed by players or AI. That is exactly what we want. We want to possess it, and that's about it. So we're going to go ahead and say pawn. So we'll call it Flapman. So this is going to be our character. So you want to double click that. We can enlarge. So the first thing I'm going to create is a component called capsule collision. The reason I'm doing that is because this is what's going to drive the collision between the objects if we hit a tree or what's happening. After that, we want to add a sprite, paper sprite. In the sprite, here you can select your sprite. But you'll notice that it's empty. So why is that? We imported our sprites and they're all there. We know that. You can see it right here. So how come we're not seeing it? Well, it's because this is just simply an image, a texture. We haven't defined that this is yet a sprite. So what we need to do is also, you'll see that this is all part of one image. This is not 2 images. This is just one image with 2 different sprites, right? So this is going to be his normal state, and this is when he's flapping for flap. Yeah. Okay. Anyways, so what do we need to do? It's pretty easy though. So what you do is you just right click sprite action and extract sprites if it has multiple sprites, which this one does. So in this window, okay, so you might need to zoom in a little here. Yeah, here we go. Okay. So that's great. So you can see that it automatically tried to extract each sprite. Now, the thing is that we don't want to change the resolution of these because that's going to lead to issues when we animate it. So we're just going to change this from auto to grid. And so each of these cells are 25 by 25. So we're going to set this one to 25. And now you can see that it splits it perfectly. So we're going to hit extract on that, and you can see that now we created 2 files down here. Perfect. So let's go back to our character and try again. I'll make sure to save this as well. All right. So in our sprite, see, now we can see that. So we're just going to choose this thing. All right. So that's our main. Great. And because we're going to be dealing with physics and stuff, these are actually very small because they're such low resolution, and I don't actually want them to be that small. So what I'm going to want to do is I'm going to gang this up. I'm going to put in a value of 10, and that's going to be the size of my character. Okay, so you can see our capsule is a little small. That's okay. We'll deal with that later. And for now, that's great. We have our character here. It obviously can't do anything yet, but we're going to change that soon. But I think the first thing to do, though, is we want to get it in the game so that we can see it there. So let's start with that. So how do we tell Unreal Engine that this is actually our player? Well, Unreal uses what's called a game mode to handle overall things, such as which blueprint is your default character. So let me just create one and I'll show you. So we just right click here as normal, and we are going to create a new blueprint class just as before, but this time we want it to be a game mode base. All right, so we create that. We'll call it BP game mode. And if we double click this, you can now see that you have a few settings. All right. So for example, you can see default pawn class. So this is what is going to be considered your character by default by this game mode. So I'm going to go in here and just search for Flapman. You can see Flapman shows up there. And you're going to compile that. And that's all we need to do for now. But we do need to do one more thing before this actually ends up being in the game, because we haven't actually set that this will be our game mode. I know it's a little confusing. Just bear with me. So you go to your settings and your project settings. So this is going to be your overall project settings. And you go to maps and modes. And you can see that this is now using a default game mode base. So we want to change this to our custom one, blueprint game mode. Perfect. So this is now setting that this is our game mode, and our game mode is setting our default pawn. So that's excellent. So if I save that now and play, you will notice that not a lot is happening. That's because we haven't yet assigned a camera. So in your Flapman blueprint, we are going to create a camera component. So create camera. All right, so the first thing, we're going to rotate it -90. And then we're just going to move it back a little bit. Now, okay, so this is a 2D game. It's going to be strictly a 2D game. Okay, so if you use a regular 3D camera like this, it's going to introduce perspective. So anything that's further away is going to appear smaller. We don't really want that for a pure 2D game. So what we're going to do is we're going to change the camera setting from perspective to orthographic. And what that means is basically that the camera will be rendered as if it was infinitely far away. This will basically mean that when you move things apart, it won't matter. You won't get a perspective difference. So if you want to learn more about that, and if I'm not really explaining it clearly, you can look it up. But yeah, that's what you want to do. So set it to orthographic, and it doesn't matter how far back you push it. It will appear the same size anyways. So just trust me on that. But we'll move it away just to keep things clean. And now let's try. Excellent. So if we play the game, you can now see your guy. However, he's very big and we don't want that. So we're gonna fix that, but that's excellent. So that's a really great first step. We're now seeing our character. Can't control him yet, but we'll get to that. I'm gonna do something here. I'm gonna drag this off so that we can just adjust this as we go. But essentially what I'm gonna do now, because the character is not actually in the scene, I'll just drag him out here for now. We'll reset the transform so that he's at the origin. And you can see that you get a preview of the camera. So I'm going to pin that so that we don't lose it. And now you can go into the camera and you can look under the orthographical settings. So you have the width. So if I adjust that, you can see that, okay. So this is sort of like the zoom, you could say, how much we'll see. So we can sort of adjust this to a good level. So I'm going to set it to something like, I mean, it's obviously hard to tell. We'll have to have the background in there, but like, I don't know. Yeah, maybe 3500. Now that's all excellent, but we can't really do anything. So I feel like before we start adding background or the blocks or anything like that, I really feel like we need to get the jump mechanic going. So let's start there. All right, so before we can actually make him jump, we're going to have to first assign input so that we can handle if the player is jumping. We need to know which button that is. So that makes sense. So let's start there. So you're gonna go to your settings, project settings, and find input down here. And now we can add bindings here. You'll have two different categories here. One is action mappings, and that's just simply if a button was pressed or released. And then you have axis mappings, which is like, for example, if you have an Xbox controller, then this is gonna be an axis. I'll explain more about that later. For now, we're just gonna use an action mapping. That seems, you know, reasonable for a jump. So we'll just call this jump. And now we can assign buttons to this. So you can really choose anything you want. If you have a gamepad and you want to play with that, if you want to play with your mouse, I'm probably just going to use my mouse for now. So left mouse button, space would be another good one. So for example, you could add that too. You could just press the plus button and add, and space bar. So now it'll jump. Well, now this will register regardless of if you press space bar or the mouse button. So we have that. That's great. So when we were playing before, you might have noticed that the guy was just sitting there. He wasn't falling down. Now, well, first just make sure you delete the flap one we added before. So when we play the game, he's not falling down. So I think before we start jumping, we should enable gravity. You could just apply it to the entire player. That would generally be how you do things. But in this case, it's going to be a little different, and I'll show you why. So I want to just take this capsule and apply gravity to that. Anything below the capsule in the hierarchy will also receive this gravity. So if you look in the physics, we're going to say simulate physics. What you also need to do is under collision, I'm just going to say block all. Now that might be confusing. Don't worry. We'll go through collisions a little bit later, but for now, just put it to block all and enable gravity. So if we try this, well, it looks like we're standing still, but we're actually not, because if you look here, our camera is now underneath our capsule in the hierarchy. So the camera is falling with the character. That's exactly why we are applying physics to this capsule alone, because now we can take our camera and drag it to the default scene route and just say attach. All right, so now the camera is disconnected from the capsule. All right, so let's try that. And you might notice that something strange is happening. We're just disappearing. Well, without going too much into that, I'll just tell you why. And it's because if you look under paper sprite, we currently have collision to block all dynamic. That means it's actually on. So let's just turn that off. Basically, the capsule is colliding with the sprite inside it. So that's not good. So let's just set that to no collision. That means it won't collide at all. While we're at it, you can turn that off as well. Generate overlap events. I'll explain more about that as well later. So let's try it again. There you go. Very cool. Very nice. So now he's falling. This is actually realistic. He is falling at a speed of 9.8 meter per second squared, which is Earth gravity. However, in video games, that generally tends to come off as floaty and slow. So a common trick is to increase the gravity. So I think let's just do that right away. To do that, you can go to your world settings, and they'll show up down here. Now you can see we can override world gravity. So we're going to do that. So Unreal's units are in centimeters. So we're going to have to think about it as in centimeters. So real Earth gravity would be 9.8 meters, right? So that would be minus 980. Okay, let's see that. That should give us a similar result to before. And it is. Very cool. So why don't we just take it to like a value of times 5 or something. So it's so close to 10 meters. So we'll just say minus 5,000. And try that. Oh, whoa. But you know what? It's probably not too bad, actually. It's feeling a lot better. Let's go with that for now. You can always change it later. Now, for the actual jump. Now we're going to get into some blueprinting. We're going to do some blueprint scripting. So go to your event graph. You'll be faced with this. We're not going to touch any of these right now. We're just going to go down a little bit and, well, let's think about this. What do we want to do? Well, I think the first thing is to access our jump button. We want to know when the player hits the jump button. So how do we do that? Well, if you remember, we created an action mapping called jump. So why don't we just go ahead and search for that? You can, if you just right click here, it will bring up the search function, and I'm just going to say jump, and see, here it is. That's our jump. When the user presses jump, this will fire. What do we want to do when that happens? Well, I think that generally we want to add a force upwards when that happens. So I'm gonna first go and drag our capsule down because that's the one we want to affect. We don't want to, for example, add it to the camera. The camera should stay static. So we'll add our capsule. So what we want to do is we want to drag out from here. And generally, like if you know what you want, the first thing I generally do is I just search for something that sounds right. So for example, I want to add a force upwards. So I'm just going to search add force. Well, there you go. Add force. See, I mean, obviously, if you don't know, then, you can, I already know this, but generally I find that it's pretty good to just search for whatever you think it's going to be. And after a while, you kind of get used to the language, so to speak, and generally what things are called. And if not, you can always Google it and it'll give you some good options for what nodes to use. But in this case, we're going to use add force and we're going to connect this to pressed. So whenever the user presses the jump button, this is going to fire. And this is now when we're going to add force. So forces are a little sneaky. So when we deal with forces, numbers generally tend to go very, very, very high. Like it might seem a little bit too high and that you did something wrong, but that's not generally the case. To alleviate this a little bit, what I'm going to do is I'm going to go into my capsule and reduce the mass, because right now it's like at 100 kilograms. That's quite a lot. So I'm just going to go down to something like 0.1. And that's going to make our character a lot lighter, which means I will have to give him less force to shoot him upwards. We're still going to have to give him quite a bit though. We want to add force in the Z because that's up direction. So let's say 10. And let's play that. And nothing's happening. Okay. Now, tricky question. Is that because our input system is not working, or is it because the force was too little? Well, a good way to check that is to just simply add after this, type print string, and you can leave it at hello. You can type something here, jumping. Totally. Cool. And now, oh, well, look at that. See that? Okay, you can't see where I'm pointing, but the mouse is too bright. But I can't do. Okay, anyways, top left window, you can see it. I'm pressing and I'm jumping, and both the mouse is working and the spacebar is working. Perfect. So it probably means that we didn't give it enough force. Let's just do something crazy. Yeah, let's do 10,000. Oh, it's still not enough. I do see him like breaking a little. Oh yeah. Oh, if I click really. There you go. Look at that. Now you can just add another 0, and then we'll find out pretty soon enough when it's too much. Let's try that. Whoa, okay. Way too much. Let's try 30,000. Oh, that's actually pretty good. Ooh. Oh, look at that. One thing that's a little interesting is that, so if you wait for a moment and let him start falling and get some speed and then jump, you notice that he barely jumps at all. And then as we go upward, he starts jumping more and more and more. Obviously, that's realistic because we're applying the same force. However, that's not quite what we want. We want him to jump the same amount every time we jump, no matter what his velocity is. So you can delete your print string here. And basically what we want to do is before we jump, we want to completely stop him in the air so that he has 0 velocity. And then we want to apply the force so that no matter what velocity we initially had, the jump will always remain the same. So you can do a little thing here. You don't only have to have one of these. So this is a reference to our capsule, right? It means that this thing operates on this. You can drag this down again, and you don't need to, you can have more than just one. So I'm just going to pull that down. All right. Again, let's just search for something. Set physics linear velocity. Let's just try that. I think that's right. It sounds right. Very cool. And so what's the new velocity? 0. Perfect. It'll stop in the air. And then we add this force. Let's try that. Just gonna play. Whoa! You see what I mean though? No matter what, the jump remains the same. Now it's starting to feel a lot more like a game. We could move on to do other things like background and stuff, but you know what? I'm feeling pretty good about this, and I feel like we're pretty close, and I think we should just finish up our character completely, and then we'll start adding the blocks in the background in. If you're with me here, you'll notice that it feels a little floaty. It feels a little slow. So here's a little bit of a nugget for you. Like basically what we're doing now is doing almost real physics. We're going up at a decreasing speed and then we turn around and we come back down at the same speed. In video games, however, that makes it feel floaty and unresponsive. So what we're going to do to our character here is to basically when we're jumping up, we're going to apply higher gravity. When he's going up, that means he's going to reach his highest point quicker. And that's going to feel very good to the player, very responsive, very snappy. However, when he starts falling, it's going to be too fast and it'll be very hard to keep up and you'll feel like you're losing control over your character and the game starts feeling a little unfair. So what we do is that when he's traveling upwards, we increase the gravity. And when he turns around and starts falling downwards, we reduce the gravity. And that way you'll get like a super snappy jump upwards. And then you can sort of, I mean, obviously in this game, we're not trying to land on anything, but if you had like more like a 2D side scroller, you would be able to judge your landing a lot better because you get that extra airtime right at the end. So then that way we kind of get the best of both worlds. Completely inaccurate, but it feels pretty good. Maybe that's a bit confusing. Let's just do it. Let's try. I'll show you what I mean. So how do we do this? Well, we're going to look at our event tick. This is the event tick. This is something that happens every single rendered frame. All right, so every frame that is rendered, this fires. And that sounds right because we want to, like this is on a frame per frame basis, right? So we're going to work from this. There are ways to modify the global gravity, but it gets a little messy. So I feel in this case, it's going to be cleaner if we just do something like this. We're going to take our capsule and we're actually going to do something very similar to the jump. So we're going to drag on out and we're just going to say add force, great. And it's going to fire every tick. See, now we're going to add a force downward constantly. Okay? So we say, I don't know. You know how it was. Minus 1,000, let's say. Let's just see what that looks like to start with. Okay, yeah. You see here now? Okay, he's falling like way too fast, but you can see how much snappier the jump is, right? You know what I'm saying? I click and it's like click. He's already, like he's at his highest point like that. And that's exactly what we want. But as, like you saw, he falls way too quickly. I'm going to do something like this. So I want to say that if the player is traveling upwards, I want this force to be on. If he's traveling downwards, I don't want the force on. So how can we do that? Well, we can look at the current velocity of our capsule. So we'll drag the capsule down again. And we say, you can say like get physics linear velocity. Great. And now we can look at the return value of this. So this spits out a three-dimensional vector. We don't really need that because we only need the z-axis, which is up and down. So you can right-click on this and say split struct. Now we have the z value. So basically, if the z value is positive, he's traveling upwards. If it's negative, he's traveling downwards. So what we can say is we'll use this little guy and say float is more than a float. So if the velocity in the z direction is more than 0, he basically is traveling upwards. So we can now use this to drive this. So here's a little super trick, pro tip. Hold down B and click. Ooh, you get something that's called a branch. We're going to wire this one into the branch. And this takes in a condition, which is this. I'm going to plug that in here. So basically, if this is true, if he is traveling upwards, true, we're going to execute this, add the force. If not, well, we don't change anything. We do nothing. That didn't work. Okay. Noob mistake. Pro tip. Plug this shit in. Okay. All right. Okay, now it should work. Yay, look at that. Okay, I forgot to do that. That's okay. Okay, look at that now. Okay, here we go. Now you can see what I'm talking about. It's like I get to my highest destination very quickly, but then I start falling slowly, giving me some time to adjust to what's happening. Because it's a pretty neat idea, I think, that, you know, you get to where you're going quickly, but then you want to look around and see what's happening. And you don't want to just fall down to your death while you're doing that. So hopefully that makes sense. Now, I think that we were probably a little too aggressive. With this, it's looking a little unnatural, but this is more just so that you can see what's going on. Because what we're going to have to do now, okay, this next bit is maybe a little confusing, but stay with me. So we're doing this every single frame, right? So if you're running a computer like mine, that's a complete beast. You're getting, let's say, 200 frames a second. then you're basically going to be applying this force 200 times per second. If you're running it on a slower machine that's running 60 FPS, you're just going to be applying that force 60 times per second. So you can see how in real life time, this can actually change the behavior of the game. That's very bad. So how do we fix that? That sounds pretty complicated. Well, it's not actually that complicated. So the event tick has a delta seconds output, which is basically the time it took to render each frame. So if it took a second to render the frame, it will spit out a 1. If it took, a tenth of a second, it will be 0.1. And why am I talking about this? Well, because you can multiply this value by the delta time to compensate for the time it took to render the frame. That way, our behavior will be the same across all types of computers. And that's really important. How do we do that? Well, we can do the same thing. We just split the struct, and we're gonna make literal float. Yeah, it's a bit of a weird name. You just learn it. This is basically just gonna create a float value, a floating point value, which was minus 1,000. Minus 1,000, and we want to say, you can just write your, so now you can just write your multiplication thing, and you can see float times float. So you get this here now. Cool, very cool. So just drag this into the delta second. So for every frame that's rendered, it's always going to multiply this value by the time it took to render the frame. And that will compensate. Now, remember, it takes like a split second to render a frame. So this is now going to multiply this value by like 0.0001, right? So, keep that in mind. But let's try that. Okay, yeah, so now we're not seeing anything. So we're definitely going to have to increase this value by, let's add 2 zeros in there. You just sort of have to find a good balance, Okay, cool. Now I'm starting to see the same thing again. So it actually turns out that Unreal Engine is already compensating for this issue internally in the add force node. You can read more about it in the documentation online. Initially, I was going to re-record this bit to correct this mistake, but in the end I decided to leave it in just so that you are aware of this issue. Now obviously in your version of this game you can just remove this whole bit and just add the force like we did before. But I'm very sorry if this is a bit confusing, but I really think it's important to understand how to deal with variable frame rates and physics when you're making a game. So hopefully you can learn from this bit. Yeah, that's pretty good. I like that. Okay, so I put it at a value of minus 50,000. That's really cool. One last thing. Sorry, I know I'm going on a lot about this controlling thing, but it's really important. This is game feel. See, I'm reading this book. Okay, I don't know where the book is. I'm reading this book about game feel, and it's very important stuff. Anyway. The last thing that I'd like to implement is that if the player holds the button down, we jump a little higher. So how can we do that? Well, we can tie that in with what we're doing here. Okay, this is a little distracting, this noodle. If you double click, you'll get like a little dot. You can sort of just move it away so that it's not in the way. All right, so how do we do this? Well, first thing is to check if the player is holding down the button. So if we look at our input action jump here, we can see pressed. Now that will only fire on the frame that the user pressed it on, and the released is the same, released on the frame. So how do we know if they're holding it down? So remember how I talked about axis mappings before? Don't worry, I'll show you. If you go to our settings, project settings, let's go back to input. I was talking about axis mapping. So what is that? Well, that's usually used if you have, for example, like an Xbox controller. It's very useful for these analog sticks, for example, because an axis mapping will return a value from 0 to 1 or negative. So for example, in your right thumbstick, if you press it up, the y-axis is going to return a 1. And if you hold it halfway down, it'll be 0.5. You release it and it's 0. Push it down, minus 1. See what I mean? You get like a floating point value in between 1 and minus 1, depending on where it is. This is the same for normal buttons. Like if you press it, it'll return 1. If you release it, it'll return 0. So that sounds like something that we want. So why don't we try adding an axis mapping? We'll call this one jump as well. I don't think it won't conflict. It's fine. Left mouse button, and I also had spacebar. So let's add the spacebar. You can just search here, actually. You don't need to like find it manually. 1985. So let's go back to our blueprint, Flatman blueprint. Instead of using this input action jump now, we're going to search again and we're going to say jump. And now you can see we have axis event. So we have axis event and axis values. And get axis value. All right, so, okay, now we know if the player is holding down the button. So what can we do with this? Well, when we're jumping, we're applying this downward force. I want to say that when we're holding down the button, we're alleviating some of this force. Not all of it. Like, we still want some of it there. We don't just want to flip back to normal gravity. But we want to definitely reduce it by quite a lot. So I'm just going to give us some space here. I'm going to do a little branch. So hold down B, press. You get a branch. Let's plug that in here. So if jump button, now you can type an equals symbol, equals to 1. Basically, if we're holding down the button, that's the condition. Well, what can we do? Now we're kind of running into a little bit of a pickle. So, you know, we could duplicate the add force and have 2 different ones, but I don't really like that solution. So I'm going to introduce it to what's called variables. Very scary stuff. But I feel like this is a good time to use one. So, you know, that's sort of how I want to approach this thing, that whenever we need something, we'll add it and I'll introduce it. Maybe you know about it, maybe you don't. But either way, hopefully it's helpful. Down here, you'll see you have a bunch of stuff. So you have a variable here. So you can add plus here. Okay, so this is a new variable now. So I'm going to call it downforce. Okay, downforce. This might not make a total amount of sense right now, but it will in a moment. Just bear with me. So we have our downforce thing. And currently, if you look up here, it's set to Boolean. That's just basically a flip between 0 and 1, false or true. Let's change that to a float, because that is what we're going to be plugging into our force. Instead of feeding this calculation straight in here, I'm going to hold down Control and disconnect that. And drag our newly created variable downforce, get downforce. Going to drag that in there, plug that in. Obviously, this is currently set to 0, but what we can do is that based on what we end up with here is we can set that variable. So if you drag the downforce in and you say set downforce, we can set this. So what we're going to do is, as we come here in our execution flow, we're going to look at if the jump button is pressed down, and if it is pressed down, that means that we want the player to jump higher, right? So then if that's true, we're going to plug it into here, set downforce. We're going to actually duplicate this now. Just going to put this above here. Remember to plug this back into your delta seconds. Double click to, whoops, organize. These get a little noodly, but you'll get used to it. And now we can set the downforce. So by doing this, we're setting our variable to something. And right now we're setting it to minus 50,000 multiplied by our delta time. But because this is when we're actually holding down the button, I want to reduce this value. So I'm going to reduce it to something like 10,000 instead. I want there to be quite a, noticeable difference. And so let's come back here. So if it's false, meaning we're not pressing the button, then we want to set the downforce to be our default value that we came up with before. All right. Hopefully this makes sense, that we have this variable downforce, which we are changing depending on if the user is holding down the jump button or not. So if we do that now, we're going to you can actually plug both of these into the execution flow. So once we've set the downforce, we then go in here, add the force, and we add the downforce. Hopefully that makes sense. Let's try and see if it works. I think, okay, so that's our general. And if I hold down, ooh, I get a longer jump. See that? We're definitely getting more air time, more hang time. And that's starting to feel really natural, because now I'm actually wanting whoa, what the hell happened there? We can exaggerate this, of course, so that you really see what I'm talking about. Set it to 0, so that you even notice more of a difference. So that's tapping, and then that's holding. Ooh, long, nice jump. It's up to you to tune this to the way, make it feel good for you. I'm going to return to minus 10,000. I thought that was pretty good. You know what this means? This means that we're actually done. We actually have our player right now. This is it. This is the jump controller. We're jumping. And all we got to do now is add some blocks in the background. Oh, wait. We're not flying through the air, though, I hear you say. Well, we're actually never going to. We're always going to be like this. What we're going to do instead is we're going to put the background in and just move that. And that way we'll get the illusion that we're moving. So why don't we do that next? All right, well done for making it this far. I'm really proud of you. I think that's enough one session. In the next episode, we're going to take a look at adding the background and adding the blocking trees and give them a random position and just have them come in infinitely. The player will also die if they touch any of the blocking trees, and we'll also add a little death animation once that happens. So I'll see you then. If you like this series and you want to see more stuff like this, then please consider subscribing. It would really help a lot, and leave a like while you're at it. And yeah, see you in the next episode.